All right, so here we go with part 2 of section 9.2. Part 2 of 9.2. We're working on standard deviations, okay? Our job in this section is to come up with a number to describe whether the data is spread or not, and we have that in the standard deviation. But what do we do if the data is given to us grouped? What do we do if we are given some sort of a hot mess like this and asked to find the standard deviation? Well, much like anything else, there's going to be a way to do it if we can just pull it apart and look at what it's saying. So I'm hoping that when you look at that histogram, you're seeing the same thing I'm seeing. That the horizontal axis is the number of courses and the vertical axis is the frequency. And so the data points in here are 1, 2, 3, 4, and 1 occurs twice, and 2 occurs 18 times, and 3 occurs 24 times, and 4 occurs 16 times. And that's what this is telling me. And so I could, if I wanted to, use one of these two formulas right here. They're exactly the same. It's just a slightly different way to approach it. This one on the right, this is the formula from our textbook, the one we've been using kind of loosely for this course. This formula on the left is just a slightly different way to write that exact same formula. Right? And I mean, you could algebraically make the one on the left look like the one on the right, or make the one on the right look like the one on the left. It really doesn't matter which one you use. But to be honest, we're going to use neither of them because we are just going to push buttons to make this happen. Okay? So here's my frequency distribution. I'm going to take this data and put it in my calculator. That's going to be my list 1. That's going to be my list 2. I don't know why I'm using a highlighter. That's going to be my list 1. That's going to be my list 2. And then I'm going to have the calculator do all the work for me. The lovely thing about this is if I can put it in here as lists, the calculator can do the work for me. So 1, 2, 3, 4, 2, 18, 24, 16. One thing I want to just talk about real quick is, remember when we first made our frequency distribution? What this frequency distribution tells me is that the original data looked like this. It was a 1 and a 1 and a 2 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 and a 2, 1, 2, 3, 4, 5, 6, and a 2 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 and a 2. I think that's 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 twos. And now I got to do a bunch of 3s, a 3 and a 3. And how many 3s? I got to do 24 of them. That's the original data set. Right? This is just a simplification of that because we have lots of repetition. When I have lots of repetition in my data set, a frequency distribution is a great way to condense it down. So when I'm putting this in here, what I'm really telling the calculator is there are 2 1s, there are 18 2s, there are 24 3s, and 16 4s. And now I'm going to tell it to go ahead and calculate those one variable statistics. My data list is list 1, and my frequency list is list 2. Okay? The list 2 is right there above the number 2 on the keypad, list 3 above the 3, and so on and so forth. And I calculate, and it tells me that the mean of this data set is 2.9, and that the standard deviation in this data set is 0.8. We'll call that a 0.84, 0.837. So round it wherever they tell me to round it, I'll go to 2, call it 8.4, or 0.84, sorry. All right. So the middle or the typical or the average person teaches 2.9 classes with a variability that's relatively small, less than 1 class. So remember, the units on this are the same as the units here. These are the classes taught. So 2.9 classes and 0.84 classes. This is not a very big number, but then this isn't very big either. So I'm not sure if this is a lot of variability or a little variability. In fact, sometimes it's really, really hard to determine whether this is a big number or whether this is a small number. So one thing that is sometimes done is we will convert a standard deviation into a coefficient of variation, where we take that standard deviation and we write that as a percent of the mean. To find a coefficient of variation, we take the standard deviation S divided by the mean x bar and then times 100%. So then for our previous example right here, if I wanted to find the coefficient of variation for this, it will be 0.84 divided by 2.9 and then of course times 100%. I'm going to need a calculator for that. So 0.84 divided by 2.9, and that's going to give me roughly 29%. The variation is 29% of the mean. Right? Sometimes this is a better number to look at because it allows you to understand whether this is big or whether this is small. It's about a third of the mean. Well, it's not big, but it's not small. It's average size, medium size, how we want to word that, right? If we went back up here and did this one, right? The mean was 7.5. If I do 1.88 divided by 7.5, I've got a mean of only 25%, or a coefficient of variation of 25%. That's smaller than what we just had, right? Didn't we just have 29%? But can I look at 8.84 and can I look at 1.88 and easily see which one is the larger relative to the data set? Standard deviation. I would have thought 1.88 was bigger than 0.84. But when I do the math, as a percent of the mean, this has a variability of about a quarter, 25%. This one's closer to a third at 29%. We can also use coefficients of variation to compare data sets. Here I have two data sets. The first one is the salary for a bunch of software engineers in Raleigh, North Carolina. The second one is for Wichita, Kansas. Right? And so what I want to do is I want to compare these data sets. So I'm going to find a mean for the data sets, and I'm going to call the first one 1 and the second one 2. So I'm going to find a mean sub 1, and I'm going to find a standard deviation for 1. I'm going to find a mean for 2, and I'm going to find a standard deviation for 2, and then I'm going to use these values right here to compare and to talk about these two data sets. Right? Now, before I can do anything, though, I got to get that data into my calculator. So let me just make this a little smaller and drag my calculator over here so it'll fit. Now I'm going to put that data in my calculator. So stat, edit. I don't need this stuff anymore, so let's go ahead and clear it out. Data set 1 is Raleigh, so 63.7. This is going to take a while, so I'll pause the video and just come back with it typed in. All right, welcome back. Moment for you, a couple minutes for me. Got all my data put in. I'm going to go stat, calculate one variable stats on list 1 only, so I'll clear that out. And this is going to give me all the 1 stuff. So the 1 stuff is a, oh, that's useless, a 61.2 mean with a standard deviation of 7.57. And now I'll do it again, stat, calculate one variable stats, for this time for list 2. I get a mean of 64.1 with a standard deviation of 10.15. Okay. So now I'm going to try to figure out what this means. Right. Well, let's do CVs for these guys too. Let's do a CV, a coefficient of variation for group 1, and a coefficient of variation for group 2. So coefficient of variation for group 1 is going to be 7.57 divided by 61.2, and I get a 12.4%. And then if I do the second group, 10.15 divided by 64.1, I get a 15.8%. Okay. So here's what I'm going to take from this. This is smaller than this. So on average, Wichita's paid more. This is smaller than this. So the variability in the salaries in Raleigh is lower than the variability of the salaries in Wichita. And that bears out here because we've got a smaller CV and a larger CV. So where do you want to work? Well, on average, these guys are paid less. On average, these guys are paid more. On average, I'm going to be closer to average here. And on average, I might be further away from average here. Okay. These are much more predictable salaries. These are less predictable. Okay. Predictable here being that there's not a lot of variability, or there's less variability. So I know it's going to be 61.2 or somewhere around there, pretty close to it, within 7.5 or so. Whereas this one is 64, but there's more variability, and because there's more variability, it could be lower or it could be higher. So when I think about the range of salaries here, smaller range, here, bigger range, because I have a larger CV, a larger standard deviation, however you want to word that. Okay. All right, that brings us to the end of section 9.2. Okay. Have a wonderful day, and then I'll see you back here for 9.3.